Okay. Hi, good morning, everybody here in Egypt participating in COP27, and hello to anyone tuning in from around the world. We are determined to achieve a 1.5 degree future, and we're ready to see all of the plans that have been discussed transition into action. Communities and municipalities, they're at the heart of the climate action, and Clearest Solutions is proud to share its advanced biological nutrient removal technology, which converts wastewater into a usable end product, algae. And this mitigates the need to landfill biosolids and also sequesters carbon, contributing to a circular economy and ensuring community sanitation needs are met. My name is Jessica Daignault. I am a professor of civil engineering at Montana Technological University. I've had the recent privilege of working with Clearest Solutions to quantify the environmental impact of their process. And it's my pleasure now to hand it over to bioresources scientist Emily Rutledge.
Thank you, Jessica. To start off, I'd like to share this quick video to give a little bit of context behind how the EcoRecover ABNR methodology works. Is it muted?
It fuels economies. Water is humanity's most vital natural resource. It fuels economies, societies, and life itself. Continued population growth and rapid industrialization will threaten water supply. Contamination caused by excess nutrients like nitrogen and phosphorus saturate our waterways and result in serious environmental, economic, and human health concerns. As a chemical-free and biologically based wastewater treatment solution, the Clearest Advanced Biological Nutrient Recovery System, otherwise known as ABNR, leverages a zero-waste process to effectively and sustainably achieve ultra-low-level nutrient results. It is highly modular and scalable and can bolt on to existing water treatment infrastructure. The patented ABNR system applies traditional biological wastewater treatment principle. The results of the process is best-in-class water quality. ABNR contains 4 core phases: the mix phase, the recover phase, the separation phase, and the harvest phase. In the mix phase, contaminated wastewater and CO2 are mixed with a blend of algae and other biological organisms to create a biodiverse mixture flow. In the recover phase, the mixture flow leaves the blend tank and enters our vertical pond system. The greenhouse structure and light source provide light for year-round, 24/7 nutrient recovery. The vertical pond system optimizes biological activity and photosynthesis. Inside, the algae metabolize nitrogen, phosphorus, CO2, and other unwanted contaminants, and rapidly divide. The dense algae culture takes over and biologically cleans the water, releasing oxygen. The vertical pond system is self-cleaning and runs continuously with zero waste. In the separation phase, advanced ultrafiltration separates the mixture flow into two different streams, the clean water stream and the recycle stream. The recycle stream sends healthy return activated algae and other biological organisms to receive new wastewater entering the blend tank, starting the treatment cycle over again. In the harvest phase, excess waste activated algae is removed from the treatment process. This algae is then leveraged in a wide range of downstream markets, which provide a unique opportunity for cost recovery. The ABNR treatment process has been shown to dramatically reduce phosphorus, nitrogen, and other constituents. The clean water stream is now free of harmful levels of contaminants. It can be safely discharged or sent back for reuse in upstream plant operations. ABNR cleans water sustainably and is administered by a state-of-the-art information management system, allowing for low-cost monitoring and accessibility from anywhere. The automated controls regulate the relationship between the biology and the mechanical processes to maximize the treatment impact. ABNR is highly modular, scalable, and flexible to meet a variety of water quality needs. Unlike traditional mechanical and chemical technologies, the system produces zero waste and has a competitive total cost of ownership. Clearis Water Recovery, simple, chemical-free nutrient recovery.
I think you have to click on the slide. Our flagship and first fully operational full-scale project is in northwest Wisconsin. This plant has a flow rate of 0.57 million kilograms per day and an average phosphorus level incoming of 4 milligrams per liter. And the eco-recover can treat this to 0.04 milligrams per liter at exit. With the dryer system, this is able to produce about 90 to 140 kilograms of dry algae biomass per day, and that means we recycle about 900 pounds of carbon dioxide per day, or 400 kilograms. Our biggest project to date, and the closer to the size of projects that we're moving forward towards, is in Waupun, Wisconsin. In this, we see a 2.4 million gallons per day flow rate, and we can produce about 900 to 1,400 kilograms of dry biomass per day, meaning we recycle 7,000 pounds of carbon dioxide per day, or 3,175 kilograms. This is an inside look at our Waupun facility. You can see all of the ABNR tubing stretches down a pretty long ways, and then we see the membrane modules and centrifuges on the right side. Our third project that is nearing completion is in Wisconsin as well. Both Mondovi and Waupun are about 75% completed, and this is a smaller plant again. We're producing about 115 kilograms per day of biomass, and that means we recycle about 68 kilograms of carbon dioxide per day. So our algae population has very high levels of proteins and carbohydrates, all determined by the New Jersey Analytical Lab, giving us a valuable product to make plant-based products after harvest. Nothing is genetically modified, and all algae species are native to the area. So our main species, Chlorella and Cenodesmus, are most commonly used in all algae-based products and materials. These plant-based products are being made using starches and other plants separated into cells and added chemical compounds to make these plant-based products. So the market is huge and continuing to grow. We currently have contracts with algae-based inks as well as algae-based foams that supply very large global companies. So with these plant-based products, we are looking at a circular economy for the ABNR process. We treat the water to nutrient limitation or below, after which that product that treats the water is recycled either back into the process or it is harvested and sold to be included in plant-based products in order to replace the petroleum-based or chemical-based products in plastics, fertilizers, chemical intermediates for makeup, things like that. So looking a little bit more in depth, when we come off the harvest phase whole cell, the algae is often used for fertilizer applications. And when we get into pre-treatment applications, we can separate the algae cell into its components, proteins, carbohydrates, lipids, and we can sell those to biofuel companies, animal feed companies, as well as those chemical intermediate companies.
So Clearis, in partnership with Montana Tech, has recently completed an International Standards Organization compliant life cycle assessment on its ABNR technology. The goal of the project was to develop some environmental impact metrics that can be used to identify areas for improvement in process efficiency, which then subsequently allows the process to be improved to reduce its environmental impact. So life cycle assessment, what it is at its core is it's a methodology that can be used to quantify environmental impact of any product or process. ISO compliance studies include 4 different key steps. So starting with goal and scope definition, inventory analysis, impact assessment, and interpretation. So the scope of this particular LCA was specifically for the manufacturing process. So this is a gate-to-gate analysis. The function of the system is to treat wastewater. And as a result, the functional unit for this analysis was selected to be environmental impact per pound of phosphorus removed from wastewater. The system was evaluated under 3 different scenarios given the constant changing nature of electricity supply and grid mix. So scenario 1 assumed that the plant would operate under 100% renewable energy. We call this our best case. Scenario 2 assumed Midwest Reliability Organization West grid mix, and so this grid mix does include 30% wind energy currently and is representative of a U.S. grid mix that does incorporate renewables. Then we also ran scenario 3. We call this our worst case, and that's for the Midwest Reliability Organization East grid mix, and this particular grid mix currently does not deploy any renewables, and so it is a fossil-based grid mix. Okay, the next key step was putting together the life cycle inventory. So this includes all of the materials, energy, and electricity required to operate the plant. And there are multiple processes that this was considered for. So the first one is the mix phase, then the recover phase, and finally separation phase, as shown on this slide and as you saw in the video. Impacts due to the actual construction of the facility were not included, as these are assumed negligible over the 40-year lifespan of the plant. Those operational impacts are much higher. Okay, so to actually assess the life cycle here, we use the greenhouse gas emissions protocol. And this method does classify emissions under 3 different scopes. Scope 1 includes emissions resultant from sources that are actually owned directly by the reporting company. An example of this would be if there was on-site fossil fuel combustion. Scope 2, this is energy that is purchased to operate the facility, so electricity, for example. And then scope 3 are emissions resultant from activities not directly owned or operated by the reporting company. Most of the emissions associated with this process are scope 2 emissions, so that electricity use at the plant. Results are really encouraging. It shows that 2.2 pounds of CO2 are sequestered per pound of biomass produced. So this is an amazing opportunity to take atmospheric CO2 and sequester that to produce a usable product. We also see stark differences under the 3 different operating scenarios that grid mix has a really big impact. So shown in the table and figure on this slide, we see fossil CO2, biogenic CO2, CO2 from land transformation, and then also CO2 uptake. We can see that the emissions are decreased by nearly 0.7 kilograms per pound of biomass just by adding that 30% wind energy in the grid mix, which is already happening, fortunately. And then results show that this process will actually be net negative completely, including all operations under 100% renewable energy grid mix. So there's so much potential here for improvement and for forward motion with uptaking carbon while also meeting really important human needs like sanitation versus just land applying biosolids. So Clearis is committed to achieving this net negative carbon operational scheme, and they plan to do that by transitioning to on-site renewables if the grid mix cannot keep up with their progress. Thank you.
So just to share a couple examples of where Clearis can be implemented, we are currently talking with a very large global pet supply company, pet feed manufacturer, and they recently received a $100 million investment to expand their plant, and they would like to explore achieving their corporate sustainability goals, ideally at the same time, which includes decarbonization, that sequestering aspect, as well as including different plant-based proteins in their animal feed, which our biomass can also provide them. The sizing metrics of the plant are in this green box here, so they're very large, but they're looking to Clearis to achieve these goals. The second example I'd like to share is a very large global automotive company, and they have a triple bottom line that they would like to meet, and they are currently in progress of a contract with Clearis to minimize their emissions as well as achieve a carbon-free energy source by the year 2050 and 100% sustainable materials within their automotive processes, whether that's plastics, materials inside the vehicles, whatever they may be looking for, and that is just something that Clearis is very capable of. So we know that a transformational shift is underway globally, and the concept of circularity, sustainability, and regeneration are no longer just buzzwords. They are changing the way that we think about industrial and municipal civil wastewater infrastructure design. These legacy wastewater treatment plants are very linear in their models. We make and design, we build them, we treat the water, repeat. Whereas the circular economy and resource recovery plants are an opportunity for continual income for the owner of the plant as we sell the biomass, and as a result, it is typically the low-cost option over a multi-year planning, like 15 or 20 years. Because this traditional wastewater plant uses so many chemicals for treatment, there's a lot of upkeep. There's also costs involved with landfilling the toxic sludge that's moving away from the wastewater treatment site. So we are bringing this cycle to an end using plant-based treatment, which converts the problem into reusable materials rather than a liquid problem to a solid problem. And we create a circular economy by selling these biomaterials, providing the owner with a continual source of income while also providing a necessary service for human life. Our leadership team at Clearis is dedicated to continuing the emission mitigation process, and we believe that is entirely achievable soon and that we will be a completely net negative company. This team does a great job pushing forward on all fronts: business, sustainability, and efficiency. I would like to open up the floor for any audience questions or comments.
Hiya, I'm Jasmine. I'm from Global Water Intelligence, so we're just a media company for water sector. We've been looking at the greenhouse gas emissions from wastewater treatment. Have you seen any technologies that are used or are being implemented to reduce methane and nitrous oxide emissions?
Technologies for what? That's not been our main focus at Clearis. I don't think we produce much methane.
So you mean traditionally, are we familiar with the impacts of the methane? Yeah. It's outside the scope of this particular company's mission, right? Because that's more relevant if you have the biosolids resultant from traditional wastewater treatment and then they burn them to dispose of them. And so I guess to that point, this is a really great technology to replace traditional wastewater treatment and completely remove the need to burn any biosolids and resultant, methane emissions. So that's another benefit of this technology. Yeah.
Thank you very much. First of all, to congratulate you, the whole team, for this important initiative. My question, number one, there is any cooperation with the local authorities how to use this development in order the local community to get benefits, the number one. And number two, if there is cooperation to share your initiative with some other universities and to have a network with the involvement of the youth, because my generation, unfortunately we are a part of the ecological crisis you face. The ecological crisis is not coming from the heavens. It's coming from negative human activities, according to the report of the scientific committee of the United Nations. So we have to change the way of thinking, the way of life, and the hope for changes is young generation. You see, we were in Glasgow. You were in Glasgow last year during the previous COP. We promised that we are going to take action after we leave UK. But because of the Russian invasion, the United States and all the countries, they started spending every day millions of dollars to buy the best, to get the best missiles, kill people, and they came to the point to say there are not funds for our commitment for the 100 billion we promised during the Paris Global Agreement. So this project is very important because it's a part of the implementation of the Paris Global Agreement and also how to get the Sustainable Development Goals of the General Assembly. So why you don't challenge also the leaders to tell them, stop giving money, killing people, and give more money to get this proposal for everybody, not only in your university. So what is your moral responsibility as representatives of the Youth Scientific Commission to challenge also the leaders and the people here to give a lot of money, to give you a white check, like we give to Maradona, to the people of the tennis? Huh? If for one individual we give white checks, what about how to protect the whole planet and the whole humanity? Huh? I want you, you are not prepared for this moral responsibility, but you have the moral responsibility also to speak, because you are speaking about the future of your kids. So how can we get the achievements of your initiative and of your activity to the local community or local level, national level, and on global level? Thank you.
Thank you. Yeah, I'm going to start to address that. So I think there were a lot of parts to that question. I'd like to speak to the fact that we did have in the United States a big legislation move through last year, the Bipartisan Infrastructure Law, and so there are billions of dollars currently in the U.S. being released to communities to improve their infrastructure. And so it is our priority right now as youth, as scientists, to share this technology at a time where funding is becoming available. This is very big. It has not happened during my lifetime, and so we're excited to be sharing this information at a time when the United States government is committed to providing communities with funding to implement new projects in infrastructure improvement, and that is very directly related to wastewater. So that would be my key response to that.
Hi, my name is Francesca Butler. I'm also from the Midwest. I go to the University of Illinois, and I'm actually here doing research on CCS, carbon capture sequestration, and this seems like it might be kind of an alternative to that idea. So it seems like this technology is a way that we can reduce kind of global CO2 emissions to get towards like that net zero idea if you all are able to scale it. So I was wondering if you could speak a little bit to the scalability of your project.
Yeah, the eco-recover is very scalable. We have really tiny plants right now. We have even like a pilot that we send out to different states, and that can be scaled up to these gigantic automotive companies that want to use this. So, you know, from 0.1 million gallons a day to probably 5 million gallons a day of wastewater treatment we're looking at.
Are there some studies? I'm Nikhil Jain from Sanicon, India. Okay. So are there studies being conducted with respect to the ambient temperature? What is the performance curve for the efficiency in removal of the nutrients as well as the production of algae that we are talking about?
We have very little operational and maintenance in these plants. The lifespan of our largest plant is 40 years, and then we do our biggest equipment maintenance every 15 years probably. So it's pretty efficient.
Okay, but my question is to do
Maybe after you can.
But my question is altogether different. The question that I ask is, in a season, in a year, the ambient temperature increases or decreases, okay?
Temperature?
The temperature, ambient temperature, the outside temperature, okay? Your passive removal of the nutrients and the production of algae is directly correlated with the ambient temperature.
I think I understand what you're saying. As the temperature changes in the Midwest, do we see changes in the efficiency of the algae growth? Yeah, we do. We also have in-greenhouse heaters, and we can get into more of this after we step down, but we're out of time.
Thank you.